Hey everybody, I was just working in my office. That's what I do. Hey, it's technically Wednesday before Thanksgiving. You're at home. I know you don't want to work on math stuff. So we're going to do a small amount that maybe you can get done today. For me, it's Tuesday. I'm making a video ahead of time because I don't want to work tomorrow either. So this is what we're going to do. It's going to be a short video on a small recap on things that we were talking about yesterday, Monday in class, and then looking forward to the next step of things, okay? So remember, we're doing what's called a hypothesis test. You're going to be making a claim about something using a testable question. A testable question is a yes or no question. It's a question, the yes or no answer that clearly indicates the kind of statistic that needs to be collected and then computed. Once I have that testable question, I can run some sort of test, and I'm going to find the probability of getting the data that I got based off of random chance or because something special seems to be happening. And if the probability that it's coming from random chance is small enough, smaller than my threshold, if that p-value is low, my null hypothesis must go. So the null hypothesis is nothing special is happening here. Nothing to see here, folks. Nothing special is happening, or the status quo is maintained, things like that. The alternate hypothesis is the opposite of that. Now, oftentimes when you're asked about this kind of stuff, you're asked for the null hypothesis first and then the alternate hypothesis, although it's actually kind of backwards. When you have a claim to make, you're actually thinking, what is my alternate hypothesis? I'm claiming that the average body temperature is not 98.6. I am claiming that this coin is not actually a fair coin and somehow it gives me heads more often than it should. Things like that, okay? And so that comes first oftentimes, even though we don't ask it that way. And then once I understand what the alternate hypothesis is, the null hypothesis is just the opposite of that. So I could say, I don't think the average body temperature is 98.6. Do I have a thought of what it was supposed to be different? No, I just don't think it is. Okay, so my alternate hypothesis is that it's not equal to 98.6. The null hypothesis is the opposite of that. It is equal to it. Or I could say, I think actually people run colder than 98.6. On average, the temperature is less than that. So alternate, average body temperature is less than 98.6. Null hypothesis is the average body temperature is greater than or equal to 98.6. The opposite negation of that, okay? And then when we have a conclusion, I can reject the null or I can fail to reject the null. I can reject the null, which means in terms of the parlance of a court case, I have proven guilty. I'm rejecting the null, accepting the alternate. I can prove guilty. Or I can fail to reject the null, which means I haven't proven the null hypothesis is true. I haven't proven the defendant is innocent. All I've done is failed to show that the defendant is guilty. And since I was already thinking the defendant is innocent, we judge the defendant as innocent. Okay, so, and then finally, the contextualized conclusion is we don't want to go out into the world and report. I did a study on the effectiveness of a certain kind of medicine, and we rejected the null. Right? No one's going to know what that means, right? So give a conclusion in the context that's going to make sense. There was sufficient evidence to show that the average body temperature is not actually 98.6. There was sufficient evidence to show that the average body temperature is less than 98.6, depending what the results are. We have done a study about body temperatures, and we have failed to show that the average body temperature is different than 98.6. We have not proven that it is 98.6. We have failed to show that it's different than 98.6. It kind of feels like a double negative sometimes. Okay, so that's what's going on there. So now the next section in our worksheet or hypothesis testing is this idea of proportions and means. And here's kind of the crux of what's going on is there's a ton of different kinds of hypothesis tests that we can run. We're going to focus on 3. And once you understand one, They're all kind of the same. You're just trying to find a certain probability and draw a right conclusion. We're going to focus in this section on predictably proportions and means. And then the next section, we'll talk about something called independence, whatever that means. All right. We have talked about these claims before. And then the question is now, are we talking about proportions or means here? The percent of marriages that end in divorce today is different than it was in 1950. That's clearly something about proportions, because it's asking what percentages. Person who meditates has a resting heart rate that's lower than the average adult resting heart rate. Okay, it's probably a mean, right? I'm using the word average, kind of hints at it. And then my resting heart rate, well, obviously my heart rate can fluctuate even when I'm resting, probably taking some sort of average amongst people, things like that. Taking vitamin C in the winter makes you less likely to catch a cold than the average person, and on average, 3.8% of the population gets a winter cold. So that one's kind of tricky, but we are comparing proportions. The proportion who takes vitamin C and gets a cold, and the proportion who doesn't take vitamin C and gets a cold, although we've used the average a couple times in there. Physics majors, math majors are more likely to graduate with honors than physics majors. More likely tends towards a proportion. Cars on I-81 drive faster. Well, I haven't given a lot of details, but we're probably talking about average speed in the two highways, so it's going to be a mean. Most cars on I-81 go faster than the speed limit. Well, I'll say most cars. That sounds like a proportion, over 50%, right? So that goes in the proportion realm. Okay, and so think to yourself, what are some key words that you might want to look for to pull out mean versus proportion? So now you can practice on these. And so I have you fill those out, and you can ask me questions about it later on. I'm not going to give you answers right now. I want you to think about what the answers to that would be. And then whenever you have hypothesis tests, the two basic categories would be one sample or two samples. You can actually have more samples, and then when you have more samples, things get more complicated, and we're not going to worry about that here, just to get the principles down. And so am I talking about comparing one group of things to a known number, or am I talking about two different groups of things? Okay, so for instance, the percent of marriages that end in divorce today is different than it was in 1950. In 1950, I have a known fixed number. So I'm looking at percent of marriages today. I'm going to collect data from one group and compare it to that number. That's a one sample test. A person who meditates has a resting heart rate that is lower than the average adult resting heart rate of 78. Well, now, the way that I have it set up right now is I already know that adults on average have a resting heart rate of 78. So now I'm going to compare it to the people who do meditate and compare that data to the known number. That's one sample. If I didn't know that number, I could collect data from those who meditate and those who don't meditate and compare those, and that would be two samples. In vitamin C, you reduce the risk of getting a cold. Again, I know what the number is if I don't use vitamin C. So I'm just comparing against that one number. So it'd be one sample. Math majors are more likely to get honors than physics majors. Math majors, physics majors, two groups, two samples. Cars at I-81 travel faster than those on 95. 81 drivers, 95 drivers, two samples. But then last one is cars on 81 go faster than the speed limit. And that's, again, speed limit's a fixed number. So therefore, I can talk about the one sample of drivers from 81. Okay, so then you can do the same thing with this data here. Like, look through it and see if you can make sense of like which one should be one sample or two sample. All right. So now, once we're able to do that, we're going to try to put it all together and actually use that Excel spreadsheet that we had, that statistics calculator that let us do confidence intervals. We'll use that to compute the p-values that, p is lower than no must go. We'll use that to compute the p-values. I don't want to do that on a static one-way video, so we're going to pick that up on Monday. What you can do between now and Monday, apart from this worksheet here, is also look at Canvas. There is a Canvas quiz hypothesis testing design that's due on Monday. So between now and Monday, you have plenty of time to take a short quiz, and you can take it multiple times. Also, go back and look at all the other Canvas quizzes that are out there and think about the ones that you haven't done yet and do them, all right? Get caught up on that kind of stuff. All right, so no synchronous class tomorrow or on Wednesday. And if you have questions for me, send me an email. Otherwise, I will see you on Monday in person, regular time, regular synchronous class. All right, take care, everybody. Have a happy Thanksgiving.